Hi, and welcome to the Space Policy Show. I'm your host, Rebecca Rose. In today's episode, we kick off a new green space series of the Space Policy Show with Seeking Climate Justice from Space. Remote sensing satellites have been providing huge amounts of data for environmental monitoring and enforcement. But how can we use the modern information architecture to get the data and imagery into the hands of those who need it the most, like researchers, policymakers, and economists? Today, Samira Patel talks to John Amos, president of SkyTruth, and Karen Jones with the Center for Space Policy and Strategy. Now over to Samira.
Thank you, Rebecca, for introducing us. Welcome, everyone, to another Space Policy Show. We're kicking off a new Green Space series, which will be quite informal, and we'll cover all things climate and the environment. This week, we have with us John Amos from SkyTruth, as well as Karen Jones from Aerospace, the Center for Space Policy and Strategy. This is a very appropriate week to kick off the series, as President Biden just returned from participating in COP26. There has been a lot of news going on right now in climate. Huntington Beach, California is still dealing with the after effects of a massive oil spill. The Washington Post just came out with an article talking about the severe gap in accurate greenhouse gas emissions data, especially methane. And then the BBC just came out with something that I want to read to you guys, where they talked about the deal at the end of COP26, which includes pledges from participating countries that says that it would cut GHG emissions from 52.4 gigatons to 41.9 gigatons by 2030. But in order to limit warming to 1.5 Celsius, emissions need to be cut to 26.6 gigatons by 2030. So this is a very timely topic, how the space community can contribute in order to tackle these issues and take the necessary action we need to protect the planet. This also emerges out of a paper that Karen and I recently wrote called Toward Environmental Accountability, Transforming Satellite Data into Action. It was through this paper that we were introduced to John and his organization, SkyTruth, which is a fantastic organization that has used satellite imagery to protect our planet's environment. John is here with us to speak more about his work. So I will take it off with John. If you want to introduce yourself and your background, it's actually quite interesting because both Karen and John come from the oil and gas industry and have ended up in this environmental space. So it would be great to hear you guys talk a little bit about that.
Well, thanks, Samira, and it's great to be here. I love talking about this stuff. And I do have perhaps an unusual background for somebody who works now in the conservation field. I did train to be a geologist, and I worked for about a decade throughout the 1990s, learning how to use satellite imagery and other remote sensing tools for minerals and oil and gas exploration and other geological exploitation of the planet. And I started SkyTruth when I became convinced that climate change was real, was a real problem, and I didn't want to spend the rest of my life actually contributing to that problem.
And then Karen, if you want to talk a little bit about your background too, with oil and gas and how you came to the more environmental side of things.
Well, I was an exploration geologist for several years in Texas and Louisiana. And it was a very exciting career. I really enjoyed it very much. I moved on and did other things, including environmental assessments throughout the world as I worked with Arthur D. Little on various environmental assessments and examining different types of oil and gas practices. I've been with Aerospace for many years now, and I'm in the Center for Space Policy and Strategy. So now I'm examining how does this matter from a policy perspective, and what can we do to really change the trajectory we're currently on. And this is a very timely discussion coming at the heels of Glasgow right now. And by the way, I don't think they're going to get anywhere close to 1.5 degrees.
Exactly. Do you guys have impressions of the COP26 that you want to share really quickly? And then we'll move on to other questions.
I I just agree with Karen that the commitments that have been made are not nearly enough, and the reductions that are proposed are not nearly fast enough. And I'm thinking that civil society needs to move beyond government if we're going to really solve this problem and stave off the worst impacts of climate change, which of course are going to fall hardest on the people on the planet who can least afford to deal with it.
Yeah, it was very
Yeah,
poignant when
and
you think about some of the people representing some of these countries. They will literally be inundated. But on a positive note, getting to net zero and balancing our carbon budget not only involves cutting emissions, but also looking at the other side of the carbon ledger. And I was very happy to see them address reforestation and the importance of swamps or peatlands. And so that was a positive note. And I'm really glad they emphasized that during COP26.
yeah, I mean, I think it's interesting to see the interactions between the policymakers and how scientific knowledge then gets to policymakers. And that's kind of where our paper emerged from, which is the idea that scientists have all this information, the space community has all this information, but it's not getting into the hands of citizens, regulators, policymakers the way that it should be. So the main central point of our paper, and I think you guys have extensive experience in figuring out how to do this. How do we move away from siloed science communities to that actionable, trusted data intelligence for policymakers? I would love to hear, especially John, if you want to start, how SkyTruth does that.
Well, Samira, what you've just presented is actually a fantastically complicated challenge. If it were as easy as just saying, well, let's produce more good data on these problems and let's make that publicly available, then I'd be optimistic that we were on the brink of solutions to these big challenges. But really, your question involves human psychology, politics, personal and group motivations, which is why challenges like climate change are so freakishly difficult. They involve almost every aspect of human weirdness, and we need to figure out solutions to solve that in tandem with the technology problems.
Yeah, and I think one of the things that SkyTruth does so well is bring that data to regular citizens for them to use, and I think it kind of covers a little bit of that human component, but taking technology and bringing it there. And I was wondering if you wanted to talk a little bit about that, about particular examples. I know there's so many. You guys have done such great work that does that.
Well, I actually started SkyTruth because after seeing so many satellite images showing stories of environmental degradation around the world that I wasn't reading about in the news or seeing on TV, I realized this technology can be a really powerful tool for confronting people with the evidence of the impact of human activities, even when it's happening on the other side of the planet or far out in the middle of the ocean. And so one of the important aspects of using satellite imagery is really starting the cascade of things that needs to happen to address these problems and solve them. And the first thing is the discovery that there is a problem by presenting people with this visual evidence of the impact of coal mining around the world, the impact of oil and gas drilling and fracking. You make the problem real and you make it visible, and therefore you make it impossible to ignore. And then the next thing that satellite imagery and remote sensing is really useful for is measuring the problem, measuring the scope and scale of the problem, the speed with which it's happening and overtaking ecosystems around the world. And by making the problem measurable, you can then engage other actors, researchers, politicians, policymakers, regulators, because you're giving them a tool they can use to scope out the severity of the problem and then measure progress, be able to track progress in restoring ecosystems, bringing these problems to heel. So I was really interested in SkyTruth being a vehicle to demonstrate those strengths of satellite imagery and remote sensing on a variety of different environmental issues.
Yeah, and I think both you and Karen have great examples of how this is done. It would be great to hear a little bit more about an example that SkyTruth has encountered, as well as something I know, Karen, you've done a lot with methane, for example. Your examples too of how the satellite data can get into the hands of citizens and policymakers.
Well, I'm happy to start with one example. One of the world's biggest gold mines is in Irian Jaya, and the company that operates that is based in New Orleans, and so the investors and the managers, everybody involved with this company, directly involved in the financial success of this company, is essentially on the other side of the planet from the main operation. And with satellite imagery, we could show that the mine tailings from this giant open pit mine were just being discharged directly into the river system, flowing downstream into the lowland rainforest and all the communities of people who lived along the river system in the lowland rainforest, and then spreading out and inundating a vast area of rainforest with mine tailings, smothering the vegetation. And with satellite imagery, we could show this clear swath of destruction and the growth of this destruction over time in real human terms, and make that visible for regulators, visible, I think, most importantly in this case, visible for the investors in that company, so that they have a real understanding of what the consequences of that operation are, and maybe have an opportunity to voice their opinion about how the company does business going forward.
John, you said something that very much resonated with me, and you used the term in human terms. And that is key, which is to really translate the data into something that's meaningful to stakeholders on the ground and to citizens. And to do that, you often need domain experts to come in to really translate this into what is toxic, how is this harming you? Also, working through partnerships to engage with the community and increase your stakeholder involvement and speak the language of the stakeholders. Make the data open, accessible, contextual, and understandable. And when you do that, there, action results, I think. And you can see this with many of SkyTruth's projects. Samira and I studied various projects. Global Fishing Watch is an excellent example. Global Forestry Watch is also a really good example of how you engage domain experts, make the data open and accessible, and they get results. Closer to home, looking at methane, that's a very interesting one because it is a gas which is invisible, and it's very wily because, for the most part, regulators think they know where to look for methane in oil and gas fields. And the reality is there are super-emitters, which are, basically releasing quite a bit. And then there's also some good actors. So how do you discern the two? And right now, a lot of the regulators are focusing on what they already know. We need to scan, in other words, they go for certain areas where they scan oil and gas wells, looking for releases, when in fact there's many areas that have been spewing for decades, and they really just escape complete regulatory notice. So World Economic Forum recently noted that we need a tiered remote sensing strategy approach. And this would involve greater emphasis on top-down to really look across the board at what are we missing? Where are those bad actors? And as John mentioned earlier, with mining, you can see it, but sometimes it's much harder to see. So this involves a little more work in examining what do we need to use as far as sensors and what type of tiered approach should we use to engage satellites, airborne surveys, and ground-based surveys to validate.
Well, Karen, that's exactly right. There's this problem again, the problem of the unknown problem. It's the thing you don't see that's going to get you, and nowhere has the problem been more acute for society and horrifying in terms of climate implications than with this problem of methane emissions. And so regulators have all been focused on more or less exactly what the industry has been telling them. So the industry has had primary responsibility for actually uncovering and scoping the industry's problem for government regulators. You can see where I'm going with this. That's not a great solution. And just as a SkyTruth example, during the early days of the BP oil spill back in 2010, BP was steadfastly telling the Coast Guard and the American public and the world really that the rate of oil gushing from their well on the seafloor was a horrifyingly large number, 1,000 barrels a day, 42,000 gallons of oil flowing into the Gulf every day. That's an incredibly large, terrible oil spill that they were admitting to. But using satellite imagery, when we independently measured the size of the oil slick and how fast it was growing, the estimate we came up with conservatively was 25 times greater than that. And ultimately, when government scientists got engaged, the measurement they came up with was 50 to 60 times greater than what the oil company was telling the world about the size of the problem. And so this is something that we see again and again. This is not a one-off example. There's a systematic evidence for systematic underreporting of pollution and problems by industry. And that's why we need data solutions that are public. We need monitoring systems and accountability measures that have public transparency and credibility brought by strong, robust partnerships to bring in those domain partners from academia, from industry, from other sectors of society, and an open, public, transparent system that everybody can weigh in on and criticize and kick the tires on, but nothing's secret. And this is a really strong role for remote sensing and satellite technology to play in providing the data streams that are the backbones of public accountability systems like that.
That's actually a really good point because one of the things that I was reading recently is the Open Data Barometer report. They just came out with their new edition, and in it, they measure data availability, open data trends throughout the world. And what they actually found is that the level of open data availability has actually decreased from the last time they published an edition. So there are quite a lot of barriers to getting to the system that you just laid out. Both you and Karen mentioned a lot of good practices, but it'd be great to hear a little bit more about kind of shifting the challenges that you see with getting to that sort of system.
Well, I'll take
I
first
recall
crack at that.
sorry.
Go ahead, Karen.
A quote from Tim Berners-Lee: "Open data starts at the top, it starts at the middle, and it starts at the bottom." This is a process which we should all be part of and engage in. And the open data movement is increasing. We've had maybe some setbacks, but there is growth. And the Open Data Charter, anyway, has been adopted by 78 national and local governments. So I am optimistic that there will be greater expectations for transparency and accountability, especially as we start to see some of the wins with various targeted projects such as SkyTruth, such as Global Fishing Watch. The ability to share this data and to see these actionable results, it will increase over time. However, you're right, Samira, that only 7% of government data is fully open now. So we have to increase that. And the US is making a concerted effort to do that. And when we say open data, it must be accessible and downloadable and usable. So with those three things, hopefully we can start to see some improvement with our environmental programs using more data and being more comprehensive in what we surveil and use and monitor.
Karen, those are such important points. The usability of open data is one of those really critical factors. So we did work for a while on to try to understand the different chemicals that are used in specific hydraulic fracturing operations at oil and gas sites, fracking. And there's been widespread concern that fracking done wrong, done poorly, done haphazardly could contaminate water supplies, possibly human drinking water supplies. And one key for scientists to know, to be able to do the tests that need to be done on groundwater to answer that question is, well, what chemicals am I looking for? I can't look for everything. I don't have enough money to do that. I need to know what's the list? What's the list of chemicals that could be showing up if these operations are causing problems? And so there was a voluntary public chemical disclosure site that the oil and gas industry established. And the industry didn't have to submit reports if they didn't want to, but voluntarily, lots of drillers were. And their reports were PDF files. And the way that the public could access and find this information was by downloading PDF files. If you know what a PDF file is, you know that it's essentially dead on arrival. It's just a lump of text. And all of the data that you need is buried in that PDF file in an essentially unusable form. So we were very happy when the Obama administration passed an open data policy to specifically call out PDFs as not being compliant with the publication of data for use by the public. And so that usability question is really critical one when it comes to determining what's truly open and what's not.
What's interesting with the term open data is it doesn't necessarily have to be free. And this brings up commercial companies that are really doing some tremendous things. If you look at Greenhouse Gas Sat, GHGSat, or KROS, and some other entities focusing on observing methane and greenhouse gases around the world, a lot of their data is behind the paywall. These are commercial companies. But you can access their data for a fee. It's downloadable and it's usable. And I think it is important to realize that the commercial satellite players have a very important role to play as we start to expand what we're looking at from an environmental perspective.
Looking at methane again, Karen, I think that's there's tremendous potential there in terms of public-private partnership on the data acquisition and data analysis. And so there's an explosion in commercial space right now. SpaceX just launched 53 more Starlink satellites on one rocket. And that trend is just accelerating. And so it's an exciting time to be in the business in terms of the potential growth we're seeing in the availability of different kinds of data to monitor and measure different kinds of not only environmental but societal problems and issues around the world. But investors need to be paid. So we need to figure out what's the ecosystem that can develop where governments are building and launching systems of a certain range of capability and making that data available widely and for free to maximize uptake and use by civil society in a way that complements the growing capabilities of the commercial constellations that are being orbited and provide opportunities for those commercial systems to leverage the free data and leverage the public engagement that's happening on those issues that can actually create new customers and drive markets for those commercial systems. And methane, I think, is a tremendous opportunity for that.
Right. I think so too. And perhaps maybe the way it will play out eventually is there will be some base products provided maybe through government or public private partnerships, and then value added derivative products, which the commercial sector could provide for an added fee. And I might say that private sector is often acquiring this information to clean up their own operations. So I think there's a clear role for government, public-private partnerships, and the commercial sector to be involved and to actually make some money in the process. And industry can clean up their oil and gas operations, their field operations, and hopefully continue to use these products in the future to avoid future pollution problems.
Can you talk a little bit about how you guys see these public and even media engagements and partnerships and actually getting to the environmental accountability piece? So we've talked a little bit about how a framework for data can develop, how these partnerships can develop, but then how do we get to the actual accountability piece? What are the barriers to that? And how do we get there with satellite data? What is the end piece is what I'm asking.
Well, I'll take a shot at that. Again, that's a very innocent sounding question, Samira. That's really complicated. Starting from data and ending up at concrete action, there's a whole lot of pieces in between and that need to be connected. But again, I think strength of the orbital technology is recognition of the problem, discovery and uncovering of the problem, and then making the problem measurable and therefore potentially actionable. And in terms of public-private partnerships playing a role in that value chain, I'm going to come back to methane again because I see tremendous opportunity here. But one example is governments launching systems like the European Space Agency's Sentinel-5 satellite has a spectacular instrument on board called Tropomi. No, I don't remember what all the words are in that acronym, but it measures atmospheric gases across fairly broad areas, but at a reasonably high level of sensitivity. And one of those gases it measures is methane. And so using the free data from this public system launched by the European Union, we can now do nearly continuous monitoring of concentration of gases in the atmosphere like methane. And again, on a regional level of detail. That's essentially a great device for tipping and queuing the more capable, more detailed, and highly targeted commercial systems that are emerging, like GHGSat. And so there's a great example showing this big cloud of high concentrations of methane in the atmosphere over the Permian Basin oil field in Texas and New Mexico. This is the world's biggest oil field right now, and it's been around for a long time, and it's got a methane problem. And so when you show that and illustrate that problem, that brings attention, public attention, to the fact that there is a methane emission and venting problem in this oil and gas field. And then the next step is, well, where are the leaks specifically? Whose facilities are the ones that are responsible for the lion's share of this methane problem? Can we identify those, pinpoint those, give those operators an opportunity to address those problems, but then ultimately make that information publicly available so that there is accountability pressure to actually address the problem rather than ignoring it. And that's a great opportunity for the government systems to trigger targeting and data collection by the more capable private systems in a way that the private systems can create data and sell that to companies to give them that opportunity to address their problems.
I'll add here that really it's the peer pressure that's so important here because the Paris Agreement is non binding. So compliant countries must lead by example, and we must influence other countries to decarbonize their economies. However, I'm saying this, and the US is also quite a hypocrite because if you look at the Tropomi data that John mentioned earlier, you see big red areas over the Permian Basin and over the San Joaquin Valley in California, of all places. So we have a lot to clean up as far as methane in the US right now. But I think using some of the methods that John described for tipping and queuing and getting more precise measurements as to where these point sources are can go a long way. And then also, as we think about that international pressure, we can also think internationally about how we can share assets. Vice President Harris recently announced a joint space capability initiative with France. It's still new, I don't know the details, but it's to focus on the climate crisis and to exchange Earth observation data and commit to a space climate observatory. So further cooperation internationally, greater pressure, peer pressure, leading by example. I'm hoping all these things will help move us in the right direction.
Yeah, I guess it was quite an innocent sounding question now that you mentioned it. But I guess part of the reason also was one of the things that we've talked about in previous discussions is that remote sensing data isn't necessarily usable in a court of law. So if someone was to put pressure legally, that's not necessarily possible. And I was wondering if you guys wanted to touch base on that a little bit as well as a particular barrier.
Well, yeah, if you don't mind, I'll jump in on that one too with some experience that we've had at SkyTruth. One of the issues that we've done a lot of work on over the years is using satellite imagery to detect oil pollution out in the ocean. And with the Huntington Beach pipeline spill, we had another opportunity to weigh in using satellite imagery to show that the oil leak actually happened quite a bit earlier than the company initially informed the public and the government about, and that precious response time was actually lost that might have kept some of the oil from washing up in coastal marshes and impacting the beach. But our experience with satellites and oil slick detection goes way back at SkyTruth. One of the questions we always get asked is when you see an oil slick on a satellite image, what happens next? And there are two areas where or two causes of oil pollution that we're really focused on now. One is oil pollution from offshore oil and gas facilities. That problem is relatively easy to solve in terms of answering who's responsible. You've got a fixed platform sitting at a location. You've got an oil slick sitting in the water next to it. It's fairly straightforward to draw the conclusion that that facility may be responsible for that pollution. And then it's a question of what's the regulatory regime in place in the waters of the country where that facility is located. What's the judicial system like, and the judicial framework for taking action based on observations like that? And that varies from country to country. Although it's relatively straightforward to assign responsibility, it's a balkanized system in terms of legal frameworks and legal capacity for countries to take action on that. The other source of pollution we are looking at is oily slicks discharged from vessels operating out in the ocean. This is a phenomenon when it's intentional that's sometimes called bilge dumping, where vessels are pumping their untreated oily bilge wastewater out directly into the ocean, something that's been illegal under international law since the early 1970s, and is rarely noticed, much less prosecuted or enforced. And so this is something we're working to change. But we've talked to legal experts about this, and when we say, well, we spotted an oil slick from this vessel, it's operating in nation X's waters, but it's flying under the flag of nation Y. Who's responsible for ensuring that that vessel is actually complying with this international law that's been in place since I was wearing bell bottoms? And it's people kind of shrug. They're like, well, it's supposed to be them, and sometimes it's supposed to be them. So internationally, we have work to do in terms of clarifying lines of legal responsibility. But when a case actually lands in court, really the key to getting any kind of technology or data accepted routinely as evidence in court is building a body of expert witness testimony. And so that is something that SkyTruth has done in some cases. And that is an opportunity, I think, for the space science community to get more actively engaged in ensuring that the fantastic robots they're building and putting up into space and the AI and analytical machines they're building to produce data from those systems, they could actually get involved in ensuring that that data becomes actionable and has real world impact down the road.
Yeah. From a country by country perspective, we need to look at, key foundations. What are the regulations, citizen participation, right to know, disclosure requirements. These are all things that each country has to have in order to kind of stop a lot of these illegal activities, whether it's illegal deforestation, illegal mining, the tapping of crude pipelines, which causes quite a bit of a mess on land. Often this is done through transnational gangs. And it's often hard for some of these countries to really crack down on some of these illegal activities. But there are some key legal foundations that need to be in place in each country to proceed with enforcement and mitigation.
I think something that you mentioned, John, at the end there of what you were saying is how the space community has an opportunity to get more involved. I think something that we all were also missing, I think, in our paper, Karen, was we don't really talk about the role of national assets. So we've talked a little bit about public-private partnerships and other sorts of things, but what is the role that you see for the space community to get involved a little bit more, as well as connect with national assets? Where do you see that role going? And for both of you, what are the future opportunities that you see for this partnership between the space community and between environmental action?
Again, great question. There's tremendous potential there. I think and we're starting to see some positive movement in that direction where defense and intelligence agencies are getting much more involved with the private sector, not only commercial businesses involved in remote sensing and space technology, but also nonprofit public good players like SkyTruth, like Global Fishing Watch. And one example of that is the Defense Innovation Unit has partnered with Global Fishing Watch, a project of which I'm extremely proud, to host a challenge on using artificial intelligence techniques to analyze satellite imagery and detect vessels operating out in the ocean that are not broadcasting a tracking signal, a public tracking signal. That's what we call the dark fleet. out in the ocean. And many of these vessels are operating innocently. They may be under no requirement to broadcast the tracking signal, but also clearly vessel operators who have maybe not so good intentions, either in terms of wanting to discharge their pollution directly into the ocean or illegally fish in some other nation's waters and steal that resource. Those vessels too often operate in the dark. So here's an opportunity to combine forces with an excellent public-facing nonprofit project, Global Fishing Watch, and the engineers and data scientists there, with Defense Innovation Unit and other smart players in machine learning and satellite image analysis in the defense and intelligence industries to come together and solve this mutual problem. And I think we'll see, and I hope we will see a lot more efforts like this, because increasingly environmental problems are not just environmental problems. They are national security and even international security issues. And as the impacts of climate change, sea level rise, resource scarcity start to manifest themselves more strongly, these environmental problems really are going to be seen more directly as human rights, human well-being, and international security issues. And that's going to call for an all hands on deck approach in terms of data collection, data distribution, data analysis, and information distribution to make that happen. I don't think we can afford to have our national assets and our smart people in the intelligence and defense communities siloed and kept separate from these very public growing problems that they have the skills and technologies to help us address.
John, I heard that a Washington think tank was using the word natural security, a combination of national security and natural resources. And I think it's very apropos when you think about what we're up against here. Countries are competing for fresh water, they're competing for protein sources, arable land, aquifers. So it makes sense that natural security is a word that maybe we should use more. And our national security assets applied to the state or the condition of our natural resources makes sense. I guess there's a few things we need to look at when we think about our national security assets, which is appropriate use. And so more conversations probably need to occur around that. But I really like the idea that the Defense Innovation Units leaning in here and proposing some innovative solutions to this.
I love that formulation, natural security. And of course, it's not enough to just show people these problems or even just measure the problems. There needs to be societal and political action taken to do something about these problems. And one thing that you'll hear again and again is how critically important it is for all the players at the negotiating table to sit down and have one common operating picture laid out in front of them. And again, that is a great opportunity for space technology to show everybody these are the agreed upon technologies, the agreed upon metrics and detectables, and here's what we've got for this issue. And Global Fishing Watch is a great example of that. Here is a global map updated every day of where all of the commercial fishing effort is happening, exactly when and where it's happening in the ocean. Now, China, Russia, US, Spain, sit down and look at this. And here are your fishing vessels. Here are our fishing vessels. Here are yours. And here's how much fishing activity the scientists tell us this part of the ocean can actually sustain. And we're 3 times over that. Now, what are we going to do about that? So important to produce the data and analysis that provides that common framework of understanding of the problem.
Right, and a shared situational awareness. I'm very interested to see how we're going to do this in the Arctic, where there is a 16-year commercial fishing ban in place. And right now, a lot of the fish are migrating north, such as the cod and I think Arctic char and others are, of course, Arctic char is already in the Arctic, but they're moving further north and the waters are getting warmer. There's a lot of fish stock up there, and this ban is in place. I think they're into year 2 of the 16-year fishing moratorium. So, how do we enforce that when we may not be able to see everything happening at some of these extreme latitudes?
Thanks both. Thank you both of you for that response. I think that's a great place to end thinking about what that framework looks like at the global stage for tackling some of these very difficult issues. If you have any final thoughts, please feel free to share them. Otherwise, uh, please check out John's organization, SkyTruth. That's skytruth.org. Very easy to find. Please share any final thoughts.
Well, again, I heard somebody say this recently. I think it was Andrew Sullivan said in an interview. I'm not optimistic, but I have hope. And maybe I'd modify that a little bit. I have optimism in terms of what opportunities technology is going to make available to us increasingly. Opportunities in terms of really understanding the scope and scale of human and social and environmental problems and the interaction between those, and uh, giving us tools that are going to be ever more increasingly powerful in terms of detection, real-time monitoring, and alerting when it looks like something bad is happening, um, and ever refined measurement of problems. So on the technology side, I'm very optimistic about that. I'm less of an optimistic in terms of um, politics in a society that seems increasingly inclined to disbelieve science and to disbelieve what uh, technologists are producing. But I have hope. Things can change. Human nature can change. Human attitudes can change. And I'm hopeful that we'll get through this and come out to the other side where um, everyone is engaged together on solving these big problems that we're confronting, particularly the problem of climate.
So I am both an optimist and a pessimist. I kind of vacillate between the two. But I think primarily I'm a pragmatist. And as we think about coming out of the wake of the UN climate change conference, COP26, it's an important time to ask ourselves, how do we rebalance our national priorities? And how do we rebalance our space priorities to support climate change related actions? So that's what I would like to leave with. What should we be looking at? What should the space investment portfolio look like to address this existential challenge?
I think that's a great place to end. We're hoping to continue discussing these questions in future space policy shows as well. Um, yeah, thank you so much, both of you, for joining us for this discussion. I think it was a great start to talking about climate and the environment a little bit more in the space community and at Aerospace, as well as uh, taking forward this information for implementation.
Thank you.
Thank you,
I
Samira.
enjoyed the conversation. Thank you, John.
Thanks, Karen. Yes, great to talk.
Thank you to John, Karen, and Samira for that great discussion. You can read more about this data to action framework in the CSPS paper, Toward Environmental Accountability, Transforming Satellite Data into Action. And thanks to our awesome production team, Colleen Stover, James Liggins, and Jordan Bingham. Check us out on Twitter at #TheSpacePolicyShow. Sign up for our latest news and alerts at aerospace.org/policy. And be sure to look for our podcast and share your favorite episodes with colleagues. We look forward to having you tune into the next episode of the Space Policy Show. And until then, take care.